You awake?
No.
All right.
He takes.
So, here's the deal. First of all, we said everything just clumped together. Had a lot of questions about isotopes. All right. The idea is this: there's only a few isotopes of any one given atom. The idea is, remember we said the other day that Zoe finds herself repulsive, right? If we put a whole bunch of Zoes in one place, they really don't want to be together. True? Now, if we put enough neutrons in there among the Zoes, we're able to get them to stay together. All right? If we put way too many neutrons in there, it has too much force, it'll come in too close, and then it kind of just explodes. All right? So if we don't have a good balance between the number of protons and the number of neutrons, the thing becomes unstable. So there are only a couple of possibilities. I mean, you can only, like up here at the top, if you figure boron, the symbol is what, 10-5 or 11-5? So that means how many neutrons here? If that's boron. How many neutrons, everybody?
5.
5. How many neutrons?
6.
6. These are probably about the only isotopes of boron, because it gets unstable. You put a few more neutrons in there, the thing just falls apart. Okay? You go further up, though, you go to like 10. 10 is like 118, 50. How many protons?
50.
50. How many neutrons?
70 or 80.
68.
68.
Oh, yeah, that's the. Yeah.
All right, if you need a calculator, it's okay, get one out. But 11 minus 5 is 6. All right, so 68. So notice you need a lot more neutrons to hold 50 protons together. It becomes more unstable. There are only a few isotopes, and you have to have about 70 plus or minus neutrons to hold those 50 protons together. Make sense? So there are only going to be a few isotopes of any type of element. Good so far. Okay? Now, ion, you guys asked a lot about isotope versus ion. Isotope. Over here, we're talking nuclear chemistry. All right, this is nuclear chemistry. This is about the nucleus. Over here, we're talking all the rest of chemistry. Anything that really is chemistry is talking about the electron. All right, all the real honest-to-God chemistry that we're going to do the most of the rest of the year is going to have the electrons going on and off. If you're an ion, it means you've either lost an electron or you've gained an electron. All right, you've got a charge. You're a charged something. All right, now polyatomic ions just mean it's got a mini atom, but it's still a charged something or other. Okay, and to become a charged something or other, you either gained an electron or lost an electron. Make sense? You see the difference? Over here, I didn't say a word about the electrons. All I was talking about is the nucleus. Over here, I'm not talking at all about the nucleus. I'm just talking about the electrons. See the difference? Okay. So, for instance, if I'm sodium, if I take a piece of sodium metal, how many protons does it have? Piece of sodium solid.
11.
11 protons. How many electrons does it have? If it's a solid piece of metal, it's neutral, so it has 11 electrons. Do you see that? If you're neutral, you have the same number of protons as you have electrons. When sodium reacts, sodium loses an electron, becomes +1. All right, that's all about the nucleus. See the difference? So isotope, you're talking about the nucleus. Ion, you're talking about whether you've gained or lost electrons. Good? Give me a thumbs up, thumb sideways, thumbs down. Everybody, to them all. That's French for all y'all. All right, if you're here or not really here, we'll talk more after when we break up in a small group. Can you kill that for a second? Take it slow.